All right, rate laws. Okay, so you want to complete this. Okay, you're going to take your reactants. Okay, it will be raised to some exponent a, which we need to find using this problem. And there's another reactant here, NO2 minus. Okay, we'll raise it to that one b. So we need to find k and then the exponents a and b. Okay, so they have this nice little data table here for us to solve this. Okay, we want to get k. We want to get exponent a and exponent b, whether it's 0, first, or second order. Okay. So the first thing we would do is we would compare. Okay, so what do you guys want to compare? To me, I'm going to compare 1 and 2. Okay, because I can see I can cancel out the 0.10 concentrations here. So we're going to compare experiment 1 to experiment 2. So that means rate 1 over rate 2 equals k, which we need to find, the concentration of NH4 plus raised to the power of A times the concentration of NO2 minus raised to the power of B. Okay, because we're trying to find the rate law here for part A. Okay, we'll do the same thing for rate 2, experiment 2. Is that rain? I don't know. I can't see. It's not rain. Okay. Oh, yes, the roof. Okay, the roof. All right, let's put in some numbers here. What do you guys have for rate 1? Okay, 7.20 times 10 to the minus 6. Okay, molar over seconds. I'm just plugging in values now. Okay, this is what I want you to do. Rate 2 will be 3.60 times 10 to the minus 6. Okay, molar over seconds equals K. Okay, let's plug in the rate 1 and the NH4 plus for rate 1. What is that? Are you getting 0.24 to the power of A? What about NO2 minus? We'll do the same thing for rate 2, experiment 2. What is NH4 plus for experiment 2? Are you guys getting 0.12 m raised to the A power? We need to find that A. And then the same thing, 0.10 molar raised to the power of B. Okay, now let's cancel things out here. Okay, I'm going to cancel the 0.10 to the power of B, 0.10 to the power of B, and we'll find these k's later. What's 7.20 times 10 to the minus 6 divided by 3.60 times 10 to the minus 6? It's 2. Okay, do that in my head. Okay, it's 2. And then 0.24 divided by 0.12 is 2. I can do that in my head, raised to the power of A. So what is A here? 1, okay? Okay, so this reactant, which is actually NH4, decays with first order kinetics. So you can bring that rate law sheet to the exam. Okay, that will tell you all the equations you need to know for something that decays with first order decay. So A is equal to 1. All right, in my black pen, okay, let's compare experiment 2 and 3, okay, because I can see this and this will cancel out. Okay, so now we'll compare experiment 2 with experiment 3. Okay, so this is rate 2 over rate 3. K, and everything is the same as before. But we now know A is 1, but I'll just leave it as A. Okay, so what do you guys get for rate 2? 3.60 times 10 to the minus 6 molarity over seconds divided by rate 3. 5.40 times 10 to the minus 6 molarity over seconds. All right, I'm just plugging numbers in here. So NH4 plus is 0.12 and 0.12. NO2 minus is 0.10. Right, the 0.12 and 0.12 to the power of 8 cancels. 0.10 divided by 0.15, what is that? 0.10 divided by 0.15. 0.66666. Do you guys know that as 2/3? Okay, let's do 3.60 times 10 to the minus 6. Divided by 5.40 times 10 to the minus 6. Yeah, so this is 0.66667, okay, which is 2/3. And this is 0.66667 raised to the power of b. So what do you think b is, this exponent? 0.66667, or 2/3 to the power of 1, is equal to 2/3. So b, just like a, is 1. Okay. So we are halfway through this problem here. So the rate is going to equal to k times NH4 raised to the first power times NO2 minus raised to the first power. Okay, by the way, the overall order of this reaction is 1 plus 1 is 2. Okay, the overall order is 2. All right, our last step here is to find rate constant k. So which one do you want to choose? You want to choose 1, 2, or 3? You can pick any one. You pick any one. I'll pick experiment 1. Okay, we can use experiment 1 values. You can use 2 or 3. It doesn't matter. Okay, lowercase k is the rate constant. All right, so experiment 1, we have the rate for experiment 1, 7.20 times 10 to the minus 6. Equals k. This is what we're trying to find now. What is NH4 plus at experiment 1? Okay, 0.24 raised to what power? 1. Okay, 0.24 big M raised to the first power. And then what is NO2 minus raised to the 1 power? For experiment 1, that concentration is 0.10. You can plug in 2 or 3, it doesn't matter, you'll get the same answer. So really you don't have to write the ones. I'm just writing it, but you don't have to write the ones because 0.24 to the power of 1 is just 0.24. All right, so what's 0.24 times 0.10? 0.024 m squared. Okay, m squared equals 7.20 times 10 to the minus 6 molar over seconds. Okay, those are the units that we see right here. All right, so our K here is going to be 7.2 times 10 to the minus 6 big M divided by, and there's a seconds in the numerator, divided by 0.024 M squared. Okay, now we have to be very vigilant with our units. Okay, we have to be very, very vigilant with our units. Okay, one of these M's will cancel out with one of these M's. Okay, leaving us with one M in the denominator. Okay, one of these M's, okay, will cancel with one of these M's, leaving us with one M in the denominator. So 7.20 times 10 to the minus 6. Divided by 0.024, 3 times 10 to the minus 4. So K is equal to 3 times 10 to the minus 4. And the denominator molar, moles over liter, in the denominator seconds. Okay, so this is our answer. So let's make everything nice, neat, and clean for our final answer. Okay, so our final answer, this is how I want you to write it. Okay, rate is equal to K, 3 times 10 to the minus 4, M to the minus 1, seconds to the minus 1. Or you can write it like that. Times NH4 to the power of 1 times NO2 minus to the power of 1. And this is our answer. Okay, we can check our answer. Okay, how can we check our answer? We'll check our answer by plugging in some values. Okay, let's use experiment 2. Okay, so experiment 2, we have 0.12 raised to the first power. .12 raised to the first power times 0.10 raised to the first power times is equal to that. 0.12 times 0.10 times 3 times 10 to the minus 4. .6 times 10 to the minus 6. All right. Okay, you guys see that? And the units also are correct, okay, because this is M, this is M. M times M is M squared. One of these M's cancels with one of these M's. So you're left with molar over seconds. So even our units are correct.
So you want the answer like that with the NH4 and the NO2 in it too? Or can we just say rate is equal to? Or do we have to like do the whole?
No, this is the answer. This is the reaction. So
Okay.
this is the rate law for this reaction.
So you have to put those.
Yeah, because this is the reaction and this is the rate law for this specific reaction. Yes. So this is the final form of the answer.